All right, let's look at the meaning of curl. All right, so more or less, curl tells you about rotation. All right, and let's try to make sense out of that. All right, so to make our life simpler, we're going to have a vector values function and where the z component is going to be 0. So if you think of a flow, it's just a flow on the xy plane. All right, then let's find the curl of that and see what we get. So it's a cross product. So I, J, K, partial with respect to x, partial with respect to y, partial with respect to z, and a v1, v2, 0. Alright, so the first component will be 0 let's see, 0 minus, there's no x component, just a partial with respect to z. Alright, is going to be, let's see, so this is, v is actually, depends on only x and y, so this is going to be 0. Alright, and then minus, alright, then partial of 0 is 0, v, so partial of 0 would be 0, right? And the only last one, so it's going to be partial of v2 with respect to x minus partial of v1 with respect to y. Alright, then so this is going to be a vector. It's going to be parallel to the k vector because you have a 0 and 0, and only non-zero component is the third component. So this tells you about the axis of rotation. So this gradient points in the direction of axis of rotation, and why would this guy right here tells you about rotation, right? So let's think about that. So let's say you have a curl turn out to be this value turned out to be positive. So let's say let's say right, so this guy, so this is going to tell you about rotation, but why is that? Let's say this guy is going to be, say, positive. All right, what does that mean? Right, so let's break that down. Right, so it's probably, let's assume that let's say this is the case, and that doesn't really imply it, but let's just say partial with respect to v, partial v2 with respect to x is positive, and negative partial of v with respect to y, let's say it's positive. Right, so I'm assuming quite a bit. Right, but this just means that partial of v1 with respect to y would be negative. Right, let's make sense out of this guy right here. Right, so this v2 is the y direction, but we are taking the partial with respect to x. So we say that v2, so the flow in the y direction as x changes. So here is the kind of a visual image. So if that's positive, as you walk along x-axis, right, y component is going to get so larger. So this is kind of what is going on. Right, so this is my visual image of partial of v2, which is the y component, with respect to x. Right, then so that's positive, means that the flow is getting stronger and stronger. And think of, there's a turbine right here. So let's say you have a turbine of some sort right here, right? And you can see that the push or flow on the left of the turbine is going to be less than the flow on the right of the turbine, which creates a rotation, counterclockwise rotation, that way. Right, so the partial of V2 with respect to x is greater than 0, tells you indicates the counterclockwise rotation. All right, how about this guy? We can do the same observation. This is so it's with respect to y, so I'm gonna do y-axis here. Right, V1 is the x component. So x component is decreasing, so the picture would be this. So start out with kind of a big and getting smaller and smaller and smaller and smaller. And again, if you visualize a turbine of some sort right here, right? So you can see that the flow on the bottom is going to be larger than flow on top. So again, it's going to indicate the counterclockwise rotation, right? So having that, this guy right here indicates counterclockwise, such a long word, rotation. Right, and the axis of rotation, you can see that this is perpendicular to the xy plane, then axis of rotation is parallel to the k-axis. So you can see that axis of rotation, you have a 0 and 0, and the only third component is non-zero. All right, so the curl tells you about points in the direction of the axis of rotation. And the magnitude kind of tells you about the rotation, right? The magnitude of rotation, how quickly it's rotating. All right, that's it. I hope that this was clear.